So, Namaskar dosto. So today our topic is elasticity. Elasticity means what? Elasticity means suppose this is a rubber. We are stretching it and it is again coming into its own place. That is regaining its shape. We are applying a force on this, and when we are removing the deforming force, when we are removing the force, the rubber is coming in its own shape. That is only known as elasticity. Okay, so in elasticity we have to know some few things. Okay, what are the things? First, types of body. About types of bodies. See, there are mainly three types of body. First type is rigid body. Okay, rigid body means what type of bodies are these? Rigid body. Rigid body is suppose a body which cannot be deformed by any external force. That is known as rigid body. Okay, so we can write the definition: a body which cannot be deformed, which cannot be deformed by any deforming force. Okay, suppose, like example, you can have many examples like stone, wood. These are all rigid body. Suppose this is one rigid body. Okay, now suppose this is one particle of rigid body. Let's put it as I, and suppose this is one particle of rigid body. So the distance, that is Rij, this is always constant. We can say Rij is always constant. Okay, second type of body is rigid body. Then comes elastic body. Okay, coming to elastic body, suppose a body shape is deformed on application of a deforming force, and it gains its original shape on the removal of the deforming force. That is only known as elastic body. So this rubber only is elastic body. We are applying one deforming force. When the deforming force is removed, it is coming into its own shape. Okay, so elastic body, we can write it a body whose shape is deformed on application of a deforming force, and when the deforming force is removed, when the deforming force is removed, the body gains its own shape, gains its own shape. That is known as elastic body. A body whose shape is deformed on application of a deforming force, and when the deforming force is removed, the body gains its own shape. Third type of body is plastic or inelastic body. Okay, plastic or inelastic body. You can write the definition by saying its name. Okay, like plastic or inelastic body, what can it be? Suppose this pen. Okay, now you cannot deform it. That is not a plastic or inelastic body. Okay, plastic or inelastic body means that I'm not saying that this pen is not a plastic or inelastic body. Okay, I'm just saying that something which you cannot deform, don't think that is plastic or inelastic body. See, plastic or inelastic body's definition is if a body is deformed on application of deforming force. Suppose I break this pen, then it will be deformed. Then I remove the deforming force, but then also the pen will not join together. Suppose like this, to break this pen. Okay, now the deforming force is not there, but then also it will not automatically go and join here because it is plastic or inelastic body. So if we write the definition of plastic or inelastic body, it will be, see, if a body is deformed, on application of deforming force, and when the deforming force is released, it continues to be remain in that same deforming condition, remain in that same deforming condition. This means condition. Okay, CONDIN above n. Okay, this means condition. Okay, so that is all about elastic or inelastic body. So one thing you understand here very wisely, that rigid body means something which you cannot deform. Okay, just let me give you an example. This is what? This is candle, and this is what? This is pen. Now if I do like this, okay, just see this. If I do like this, the candle is broken and it will not get repaired without if I remove the deforming force. I applied deforming force and the candle got broken, but as soon as I remove the deforming force, it will not be again the same candle. Okay, that is known as plastic or inelastic body. Now see, this is one, consider it as metallic pen or pen of steel. Now I am trying to deform it like this. I am trying to deform it, but it is not getting deformed. That is, it is rigid body. And this candle is inelastic body, and elastic body is this thing, rubber. So the difference of rigid body and inelastic body is that rigid bodies can be deformed, but you cannot deform by applying your deforming force. That is, your deforming force is not sufficient to deform the body. But this elastic body is that, but this elastic body is like you can deform it and it will not come in its original shape. It will be in its deformed shape. Like I have broken, it is not broken only. My mom gonna beat me now. Okay, so you understood the difference between rigid body and inelastic body. Rigid body is subjected to change, but it is not changed. That is, the force applied is not that much sufficient that it can change its shape. That is known as rigid body. But inelastic body is not that. Inelastic body is, you can change the body, but it will not come in its original shape when the deforming force is removed. Okay, now coming to what is elasticity. That is what is the topic we are studying about. Talking about elasticity, okay, so what is elasticity? See, elasticity is that property by virtue of which material of a body, by virtue of which it opposes any change in its shape or size when deforming force is applied on it, and recovers its original state as soon as deforming force is removed. Just hear this. Okay, means I am writing this, just see this carefully. 1 second. Alright, let's go. Elasticity. Okay. Definition. We're going to write the definition. See, definition is elasticity is that property of material by virtue of which it opposes any change in its shape or size, any change in its shape or size when deforming force is applied. When deforming force is applied and recovers when the force is removed. Okay, so this is the definition of elasticity. That is, a body always opposes the force that wants to change its shape now and comes back in its own shape when the force is removed. So a body will always oppose the force that changes its shape. You remember this thing. Now suppose if anyone asks you which is more elastic, rubber or steel, what will you say? Obviously say rubber, but that's not correct. See, by applying a very less force, we are deforming the shape of the rubber. Okay, that is the opposing force of the rubber. That is the force. I am applying a force on the rubber, and the rubber is also applying another opposing force to oppose the force applied by me, but it is not able to do. My force is overcoming the opposing force of the rubber. But when I am going to deform any steel, then I cannot deform it. Why? Because the steel is also opposing my force, and the opposing force given by the steel overcomes my force. That's why my force is not able to deform the steel. So when someone asks you whether steel or rubber is more elastic, you will say steel is more elastic than rubber because let's write this, because when these two bodies are deformed by deforming force, steel opposes the force more than the steel opposes the deforming force more than the rubber. Okay, now you'll see there are some conditions of elasticity or like that, or that you will study from the book only. Okay, that's not that much tough. Okay, now coming to stress or stress. Now there will be few terms, okay, which you need to know now. Among them, one of the term is stress. See, what is stress? Stress. Suppose this is one metallic wire. Okay, now we're applying on force downside, so it will elongate. So it is elongating. This will be the new shape. I think you are not able to see it. Now you will be able to see it. This is the after elongation. Okay, so a force is applied. Similar force will be applied by the similar opposing force will be applied by this steel wire. that is this side also opposing force will act. Okay. Now if we want to say stress, what is the stress? That is this force acting per unit area, that is only stress. There is nothing but pressure force per unit area. So you can say stress equal to this force by the area, that is area of cross section of this base, F by A. But this is not applicable. We have to write definition. Suppose when, so let us write definition. When a deforming force acts on a body, then due to this, what to say, due to elastic property of the body, an internal force is generated, or generated of the body, an internal, because then I'll see we're applying force, this will elongate, this will, if after removing this force the body remains in this position, then it is not elastic body, this becomes inelastic or plastic body. But after I remove this force, it will again regain its force. So we can say the property of the body on then due to elastic property of the body, an internal restoring force is generated. Okay, generated by the body. This force acting per unit area of cross section of the deformed body, unit area of cross section of the deformed body is called as stress. Okay, mathematical explanation is this: stress equal to F by A. Okay, but since you have to know the definition, I am writing this. Okay, now see this stress. See, what we have seen here, that force is applied this side and another force is applied, means the internal force is acting on the upward side. Now for perfectly elastic body, you will write it as note: for perfectly elastic body, the value of external force is equal to internal force. There is the internal force that is generated on the body and the force that is applied on the outside, that becomes equal. Okay, now we have to find the dimension of the stress. So dimension is of the stress. Dimension of the stress is force ml t to the power minus 2, area, that is L square. So it will become ml to the power minus 1 t to the power minus 2. And what is the unit? Unit is very simple, that is the unit of pressure, but we cannot write here. What we cannot write? Sorry, we cannot write Pascal, because that is the unit of pressure. But Pascal is only Newton per meter square. Okay. Now there are different types of stress. First type of stress is longitudinal stress. This is only known as longitudinal stress. This stress, the longitudinal stress, is nothing but the stress which occurs due to deformation of body along its length. So we can write it longitudinal stress. Okay, this is longitudinal stress. Now another stress is there, and that is volume stress. Volume stress. Suppose this is one sphere. of volume V. Now suppose force is applied here, this side, and this side, so it will expand. So this is, suppose let this be the expansion, so this expansion is known as delta V, and means when the volume of the body changes by external force, then the internal restoring force acts per unit area on the body is called volume stress. Change in the volume of the body, that is volume stress. Change in the length of the body, that is longitudinal stress. Now coming another stress which is quite interesting but not that much. Okay, not that much hard, I wanted to say that. Shear stress. Suppose this is one rectangular thing. Okay, now suppose this known as ABCD. This AD is fixed, but when you are applying one force tangentially, suppose force is applied, this BC becomes deformed. So suppose this becomes BC. Okay, this is another, let's name this as beta C dash. So this becomes beta C dash. So the angle created by this, that is, let's name this as theta. This is the angle created by this. That is only we call it shear stress. See, when you write the definition will be when tangential force acting on the body keeping its AD fixed, then the shape of the body changes but volume remains same. In this case you can say that the deforming force acting per unit area is called as shear stress. Okay. Okay, shear stress. These three types of stress were there. Now coming to strain, another fundamental thing. Strain. What is this strain? We have learned about stress. Now coming to strain. See, strain is nothing. Definition I am not writing. I am just writing the mathematical form. Strain is the change of the dimension of the body. Change of the dimension of body by original dimension of the body. Okay, this is strain. We have read about stress, that stress is the force per unit area, but strain is change of the dimension of the body by original dimension of the body. So now if anyone asks you which is more fundamental out of stress and strain, you will answer strain. Why? Because strain is the delta dimension by the original dimension. If there is no strain, you cannot have stress. If there is no change of the dimension of the body, you can say this, that stress, out of stress and strain, strain is more fundamental because no strain, no stress. Okay. Similarly, you have longitudinal strain. That will be what? Delta L by capital L. Delta L is change in the length of the body by the original length. You have volume strain. Volume strain is delta V by capital V. Delta V is the change in the volume by the original volume of the body. And you have shearing strain. Shearing strain means this theta is called the shearing strain. Okay. So you have read all about strain. Now coming to another thing, that is elastic limit and perfectly elastic body. See, I'll teach you Hooke's law, Poisson's ratio, Bulk's modulus, rigidity modulus. These all things are very simple. This video will be on that only, because another thing is there which is very interesting, the graph between stress and strain. That I'll do in the next class, but that is very, very interesting. Today only theory will be there. Next class maybe you can do 2 to 3 numericals, and you know that I do numericals in like in a separate video at the end of the chapter. Okay, so okay, let's go. Perfectly elastic body. What is this perfectly elastic body? I've also told earlier that for perfectly elastic body, the deforming force is equal to the force to the internal restoring force of the body. I've said this. But what is perfectly elastic body? Suppose a body is deformed by external force. Now, the removal of the deforming force, the body regains exactly its own shape. See, in case of rubber, if you elongate it, it will gain its shape, but I don't think it gains it. There is a very slight, like you can say, change in its shape after removing the deforming force. But perfectly elastic bodies are those, like after removing the deforming body, you can get its original shape. So I'm writing just what is this perfectly elastic body. After removing the deforming force, after removing the deforming force, the original shape is regained. Those are known as perfectly elastic body. And what is elastic limit? Sure. Where the rubber end? Here is the rubber. See, this is rubber. Now I am stretching it. I removed the deforming force. It came back into its own position. Now elastic limit. Just elastic limit. Okay. Elastic limit means, suppose I am stretching it. Okay. Now I stretch up to means. What I want to say is that, suppose I am stretching this rubber. Now this rubber can be broken. So elastic limit means the maximum value of deforming force up to which the body behaves like a perfectly elastic body. That is known as elastic limit. Suppose stretching, and suppose after this force the rubber will get broken. Okay, let's see. I'm stretching. The rubber is broken. Means before snapping of the this rubber, the force that is given, that is only known as the elastic limit. See, the maximum value of deforming force up to which a body behaves like a perfectly elastic body, is called as elastic limit. Okay. See, in this today's video, it's getting long. So you remember, you study these things. Next class, that is next class only, we'll study about Hooke's law, then Poisson's ratio, rigidity modulus, Buck's modulus, the relation between them. These things we will study, and also the graph between stress and strain we will also study in the next class. Okay. So study the things. If you have any problem, write in the comment section. I'll try to solve it out. I hope the previous chapter, that is gravitation, you have studied it well. Okay. So study. Goodbye. Thank you.